Alright, I know it's been about 2 years since I've posted anything about the greenhouse. I'm going to give a couple of updates. What we're looking at right now is my new heater that I've designed and built. The first heater that was in here was a wood pellet stove that had been modified to burn waste motor oil. After 3 years of using it and 2 different modifications to do different burner types, I came up with a pretty good system coming off of a project that I saw on the internet using blasting air and a drip line inside the blower tube. And this spring I had a meltdown in that stove, left the door open trying to clean it out, and melted down both blower motors, auger motor, all the controls. The only thing that I was able to save was the actual black iron pipe that I had made the burner out of. So coming on to this year, I'd almost decided not even to start the greenhouse up this winter, but come up with the idea of taking this tank and converting it into a oil burning stove. So this is a 45-gallon air compressor tank. It used to be a medical air tank. So it has a nice feet on it to support it off the ground. So I come in onto this end, cut a hole into it, framed up a door, and then cut the hole for the blow tube to go into the side. So we got a inflation fan that's normally used in greenhouse inflation between the 2 pieces of plastic. Had to modify it by putting a different motor on it. The motor that came on this one was already shot, so I found a pretty heavy duty motor to put on it that doesn't pull a lot of energy, and got that going. Downsized it from 3 inches to 1/2-inch black iron, 3/4 black iron, using a couple of interesting fittings. That's actually a drain coupling that is clamped onto the end of that black iron elbow. You can see the copper line going in with my dripper. The plate, or the orange that you see, is gasket material that I had to put around it to keep the smoke from coming back into the greenhouse. It's got a pretty good drip going on it right now, and that oil is coming from through a filter and then out of a current 3.5-gallon bucket that I am pressurizing. That white tube is coming off of a basic aquarium pump, pressurizing it. I don't know what kind of pressure I'm getting, but I did that so that I can get a consistent drip throughout the whole evening. Normally, if you were to set this up gravity feed as the bucket up top would get empty, the amount of oil that was being dropped would decrease and eventually the fire would go out. So the second tube that you see out in front right here that's going up, it's a secondary air tube coming off of the fan. The amount of air that I'm able to get in there with that 3/4 black iron wasn't enough, so I added another blower, actually feeding good fresh air right into the top of the tank. And then in this door that I built, we'll open this up, we'll see what we got on the inside. That's a pretty hot fire, doing pretty good. You can see the drip rate that I've got, pretty decent feed rate. We got a nice hot fire in there, almost no smoke. Doing a pretty good job. This building is a 12 by 20 with I believe it's a 9-foot ceiling, and this heater is producing enough heat with the walls deflated. You can see the plastic's just kind of sitting on itself. I'll do a shot of the greenhouse as it sits right now. Plastic's just drooping. There's no inflation, don't have a whole lot of plants in it, and I'm maintaining 85 degrees in here right now. It's actually getting so hot my ventilation fan's turning on, and having to run exhaust in. The fan's actually blowing to keep it cool. What we got going on, we're going to be doing some tomatoes in the grow bed, some cucumbers in this Dutch bucket system, and going to be doing some lettuce in a raft system. Just started this. This is December the 17th. Planted the seeds about 3-4 days ago. So I've been doing some test runs for about a month on the heater, getting things going. And the other day I had to go to this 3.5-gallon bucket because my original fuel tank was a fuel tank that came out of a lawnmower, and from continuously pressurizing it, you can see this crack showed up, and doesn't do real well to pressurize a tank that's not designed for it, and eventually gave way. So I come in here the other day, and we were fixing to have a night that was going to be cold enough to need the heat, so I had to rig this bucket up really quick. I've got a coupling coming through the bottom of the bucket to feed the oil down. That actually rises about 1/2 inch inside the bucket to keep any sludge from coming in and any water. This was an interesting little setup. This is actually a clamping hookup for a Intex saltwater pool system. It's for clamping over 1.5 inch PVC or straight pipe, and that's what's inside the bucket is a 1.5 inch PVC coupling. This is clamped onto with the cap, and then the hose that pressurizes it. I don't know if you can tell, but the dome of the bucket has got yeah, you can see the crown on the lid of that bucket, so we show I've got pressure in there. And the fish tank pump does a really good job maintaining pressure in there. It's designed for pressure because it's got to be able to push air to the bottom of the aquarium. So that's my heater setup. It's running really well. I've been very happy with what I've got here. My next upgrade, I'm actually going to put a control system on it with a temperature sender on the exhaust and a fuel shutoff solenoid, so that in the middle of the night, if the fire goes out, it'll shut my fuel supply and not flood the heater up, which I've had done a couple of times. The pump that you see center screen right there is actually a vacuum pump that I use to suck the oil out of the burner and clean it all back up to get ready to burn again. Otherwise, it'll just smoke the whole place up if I don't suck all that oil up. But that's the heater for now, and Lord willing, we'll see you guys next time.